So let's talk about our acids and bases. Now, we were talking about how to check pH, if it's an acid, if it's a base. So one of the properties of acids and bases is that acids neutralize bases, and one of the properties of bases is that bases neutralize acids. Well, guess what? The acid will react with the base to make salt and water. So this is a special kind of double replacement, if you remember the double replacements. This is a special kind of double replacement where the H and the OH combine, so H and the OH combine to make HOH, which is water. And then the other things, the other ions, chlorine and sodium combine to make sodium chloride, which is also known as salt. So we take an acid and a base, something very nasty, we mix them together, and all we end up is salt and water. Now you might say, oh, that seems easy. Well, it could be easy like that, where salt is salt, but it could be a little more complicated. Oh, go back. Where we have sulfuric acid, H2SO4, plus lithium hydroxide, LiOH, and if you notice, there's two H's, and they need to bind with two OH's. Notice the two in the front, bouncing equations. Oh, I remember that stuff, I think. So we end up with two waters, and the salt, Li is a +1, SO4 is a -2. Remember that stuff from such a long time ago? So you have to crisscross to make the Li2SO4, so it balances. So here we're making the same thing. We have an acid, we have a base, and we end up with a salt. Now remember, a salt is anything with a positive ion and a negative ion. Doesn't have to be sodium chloride. This is table salt, but this is a lithium sulfate, which is another salt. And anything with a metal and a nonmetal, or an ion and a cation, is a salt plus water. Okay, so one thing to notice is that you have an H plus an OH makes the water. So that's part of what's going on with the acids neutralizing the bases. Now, so here we have in detail the H plus the OH in water. So we know acids and bases make water. So the H plus the OH reacts to make HOH, which is H2O, which is water. Now, notice this is a double arrow. This is an equilibrium. Okay, so what's happening in water, plain water, is that all of it is not water. A very, very small amount of it is water breaking up into H's and OH's. Now, yes, it's true. The H and the OH combine and they make water. But in water, a very small amount is going the opposite direction. That's what's called the self-ionization of water, where you have the water breaking up into the ions. And this is related to pure water, and we're talking about the neutral pH. The pH of neutral water is 7, and that's when the H equals the OH. So neutral water, purified water, distilled water, deionized water has, or should I say breaks up into the H plus and the OH minus a very, very tiny amount. How much? That relates to this number 7, which you'll see in a second. Okay, so lots of words. So what happens with water is that water separates, called self-ionization, and here it is, the H2O separates into H plus and OH. And of course, this H plus can join up with another water molecule to make something called a hydronium ion, H3O+. Now, some, depending on where you're reading it or what you're looking at, sometimes they talk about acids that give off H+. Some acids have this H3O+, the hydronium ion. So in college, you'll see this. So if you see it, don't freak out. That's all it is just an H plus attached to a water. So this also goes back and forth, so it releases the H's, so you have the H in the water. So that's really what's going on. So let's talk about this concentration. Now, in pure water, the H's and the OH equal each other. What do they equal? They equal this molarity. And what's a molarity? That's a moles per liter. And I think we did a little bit of that. I'm not sure if I remember it. I'm sure you don't remember it. So the big M is molarity, moles per liter. So this is the concentration, moles per liter, 1 times 10 to the minus 7. This is where that 7 comes from, the pH of 7. Okay, so we'll talk about that. Okay, so concentration and molarity. Concentration is how much solute and solvent. The symbol for concentration is these brackety parentheses things. So you say you want the concentration of the H plus ion. You draw these little brackets. Is 1.0 times 10 to the minus 7 m, or molarity. Okay, so you don't say it's dilute, it's concentrated. We're scientists. We want numbers. We want molarity. So what's the molarity? In water, there is 1 times 10 to the minus 7 molarity, moles of this per liter of water, which is a very tiny, tiny amount, in water. Okay, so here's molarity again. Molarity is number of moles in solute of 1 liter of solution. So if we had to do molarity calculations, which, lucky for you, we're not going to do, but if you did, here they are. Moles of solution divided by liter solution, moles per liter. So the higher the molarity, the more concentrated it is. So 3 molar hydrochloric acid is 3 times more concentrated than 1 molar hydrochloric acid. And of course, to do any calculations, if you want to find the moles, you take the grams, you divide it by the molar mass to find the moles. So you remember that mole stuff from way back when? And just 6-2 was mole day, so... Okay, so now let's relate that pH with molarity. So pH goes from 0 to 14, roughly. Neutral solutions have a pH of 7, true. And pH of 0 is a strong acid, so we saw that before. pH of 14 is a strong base over here. So here we have the same chart we had before. Acid on this side, neutral at 7, and base at 14. Well, look at the bottom here. These are the numbers 1 times 10 to the what? To the 1, to the 0. This is 1 times 10 to the minus 1. So if you had an acid that had a concentration of H ions of 10 to the minus 1, that would be the molarity of the solution, which we can calculate. So the molarity of solution will have a pH of the H concentration is this number here. So this is, you ready for the shortcut? If we were at school and we were using calculators, we'd have fun playing with the log button on the calculator, finding the pH with the log, blah, 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 blah. But just look at the number. Do it the easy way. Look at the number. It's a minus 1. pH is the negative log. It's just that number. That's it. pH of minus 10 to the minus 2, pH is 2. 10 to the minus 3, 3, 4, 4, 5, 5. Mr. G, what about the minus sign? It's negative log, which you'll see in a minute. So over here, this concentration is very low. The pH is 10 to the minus 14. And if you did that with numbers, that's got 14 zeros there. So it's really, really tiny amount of hydrogens, but it has a lot of H's, OHs. So that makes it a strong base. Okay, so here's the practice. pH scale stands for the negative log, get out my log, of the hydrogen ion concentration. So here is pH equals negative log of H plus. I think they actually put this on the AP exam. I don't know why. It's really easy. So if you have the hydrogen concentration of an acid that is 1 times 10 to the minus 7, this is the hydrogen ion concentration, the pH would be this number, 7, which is neutral. What about the minus? It's negative log, so you make the minus disappear. So just look at the number. Then you have a pH of 1 times 10 to the minus 3. That would mean it has a pH of this number, 3, which makes it an acid. If it has a hydrogen concentration of minus 10, guess what? It would have a pH of 10, which makes it a base. So all you're doing is just looking at this exponent and dropping the minus. That's it. I mean, we can go on in details if you want math stuff, but it's the end of the year, and just, who cares? Just look right there. Okay. So, how do you do it officially? Well, when you're in college, this is what you'll be doing. You take the negative log of the hydrogen concentration. So you figure out what the hydrogen concentration is. Here it is. And to figure it out, you put this in your calculator and you hit the log button, log of this. And when you do the log of this, it gives you going to be minus 7, but it's going to give you have to take the negative log, so minus 7 is 7. So all you're doing is just look at this number. That's the pH. That's it. It's easy. But Mr. G, what if it's not exactly that? Well, it's coming up later. You'll see in a second. Okay, so remember the pH, if it's greater than 7, it's a base. If it's less than 7, it's an acid. And if it is 7, right at the 0, right at 7, it is neutral. So here we have pH concentration. Here's the pH concentration. It's a minus 2. Boop. pH is 2. It's an acid. Okay? So if it's simple like this, 1 times 10 to the minus 9, the pH is 9. So this is going the other way, where I give you a pH and you find the H concentration. All it is 1 times 10 to the negative 9. This number climbs up there. All it is taking the number from up there and down there. That's the easy way to do it. Now, this is the hard way to do it. This is using your calculator. What if you get this? 4.2 times 10 to the minus 10. Now, of course, this is the Mr. G version. This is the long way and the short way. The long way is you take out your calculator. You take this number, you type the little log, and then you put this number in there, and then you hit enter. And when you do that, like this, here's it is. So it's the negative log of that number, and here's the number. You parenthesize it because it's confusing. And when you do this, it's going to give you a number of 9.38. That is the official pH, 9.38. But let's pause for a second. Look at this number. It's a 10. Is 9 close to 10? Yes, it is. Is it exactly 10? No, but it's close. So, guess what? If you had a multiple choice question and the number was close to 10, guess what? That's the right answer. That's it. Pick the closest answer. Don't waste your time pushing buttons in the calculator. Just pick the closest answer. It's really easy. Okay? So there you go. That's how you do it. Okay? So now let's do it the other way. Determine the hydrogen concentration of a solution with pH of 6.35. If we were in class and we all had our calculators and I'd be spending time with you trying to push buttons in the calculator, all it's doing is doing the opposite. So what you're doing is you're unlogging it. What's unlogging? It's the 10 to the minus whatever the pH number is. This is a pH of 6.35. Now, look, it's a pH of 6. So guess what the pH is going to be? Close to 6. Look what it is. Minus 7. That's close to 6. So really, what you put in your calculator, if you bothered putting in your calculator, it would be the 10 to the minus 6.35. You hit the button, and it'll give you this number, 4.47 times 10 to the minus 7. Mr. G, am I going to have to... Look, 6, 7. Pick the closest number. There's not going to be a number that's going to be far. On an AP test, they might put it close, but on my test, it's going to be easy. So don't worry about it. Okay? So all you're doing is you're putting it in the log place. Okay. Now, this is where we get confused. So, you ready? I'm going to teach it to you, but don't worry about it until college. Then you got to worry about it. Okay? It's the POH. What the heck is a POH? A POH is the concentration of the OH. Duh. Okay, so it's the same thing, except it's the negative log of the OH concentration. So to solve for the POH, you do the same thing with the calculator, blah, blah, blah. If the POH, and this is the confusing part, so this is why I'm telling you to ignore this page. If it's less than 7, it's basic. If it equals 7, obviously it's neutral. And if it's greater than 7, it's an acid. Isn't that the opposite of pH? Yes, it is. And you'll see why in a second. Because pH plus POH will always equal 14. Okay, so if you have a pH, something that's neutral, a pH of 7, and if POH is 7, 7 and 7 equals 14. Ta-da! Is that hard? No. Okay, so that's all you need to do. So if you had to figure out what the POH is or the pH is, all you need to do is you add them, and they equal 14. Now, this is the easy way to do it. There's a long and a hard way to do it. I think talking about pH is a little too much. We need to talk about, don't worry about the POH, but the pH. This is level 1, so I'm going to teach it to you so you know it. So when you get to college 2 years from now, you'll be set. Okay, so the pH is a POH of 11.2. So telling you what the POH is. So what do you find the pH? You subtract it from 14. pH is 2.8. And everything goes around the pH. So pH being 2.8 means it's an acid. Why do they have to do that? Why is it so complicated? What's the pH of a solution? Oh, what's the pH of a solution with an OH of this number? Okay, you ready for the quick answer? The quick answer is, well, here, let's see. First, you find the pH. Find the POH. There you go. The pH is 10.4. You find the pH by subtracting 14. So 14 minus 10 is 3.6. Go back. So the pH is 3.6, which is an acid. Mr. G, that's so complicated. Let's pause for a second and look. Look, this is the POH concentration. The POH concentration, look, it's close to 11. 14 minus 11 is 3. Oh, what's the answer down here? 3.6. Done. Done. Don't overthink it. Here is a carbonated soft drink that has a hydrogen concentration of 7.3, 10 to the minus 7. What's the pH and the POH of the drink? If you know the pH, you know the POH. If you know the POH, you know the pH. So this is the H concentration, 10 to the minus 7. You know it's going to be close to 7, but it's not exactly 7. So it's going to be a little bit less than 7. So if you push this button in the calculator,